In this quiz problem, after a long time, the switch closes at t is equal to 0. So the switch is going to be closed like this. Our voltage is going in this direction. Our current is going to be going in this direction. That's because the voltage delivers the current. Taking the path of least resistance, it's going to go through here. Now for part A, in the circuit, the capacitor is charged with an initial voltage of our voltage source. And this is prior to our switch closing at t is equal to 0. So before t is equal to 0, before this switch is here, let's say the switch is not here, we are then going to have the voltage go around like this, like this, like this, and back this way. And so that charges this capacitor. And when it charges this capacitor at t is equal to 0, it's going to have 6 volts. Once the switch is closed, it's going to be discharged, and our V of C is going to equal 0. It's important to note this is after switch close. So V of C, again, is 0. Knowing this, we can write an equation. We're going to say that our V of C, when time is greater than or equal to 0, is equal to, we are going to have VC, and this VC is the max time. So this is what we're looking at now. It's to infinity, and then it's going to be minus. Then in here, we are going to take our derivative, and from the derivative, we're going to get VC, and then we're going to have to the infinity minus VC, and then we're going to have 0 from here. And this is because, well, it is approaching 0. So we have one side of a number line at infinity and one side at negative infinity. And so as we come to 0, we're approaching it like this, and then we're going to infinity. So that's what that would look like. Now at V is to infinity, after the switch is closed, we can say that this is 0, because after the switch closes, V is equal to C, and after the switch closed, VC is going to infinity, so this is 0. Likewise, this is going to be 0. Now since we're in the time domain, we have to have this E times negative t divided by the equivalence of these two values. And since they're in series, it's going to be RC equivalent. This VC, after it's at 0, we know to be 6 volts, so it's going to be a 6 here. Now we're going to have to deal with this RCEQ. To find our RCEQ for this particular circuit, we are just going to have the resistance, so 10 cubed, which is the kilo, times our 500 nanofarads, which is 10 to the negative 9th. And in doing this, we are going to get 5 times 10 to the negative 4th. So this is going to go into our RCEQ. When we rewrite this, we're going to have our VC, t is greater than or equal to 0, and this is equal to, we have our 6 volts here, we have an E, and then we have this negative t divided by 5 times 10 to the negative 4th. When we go to write in our answer, we have this 6. Then we have our E right here times the t. So we can't have this division. What we're going to do instead is say that we have our VC, and then t greater than or equal to 0 is equal to a 6e negative, and then we are going to have to divide all of this, or we're going to have 1 divided by all of this, since it is in the denominator. And after we do that, we are going to get 2000. So we're going to have e to the negative 2000t, and that is going to be the answer and how to go about this problem.